Hi, this is Josh from Over the Shoulder Coding, and today I'm going over day 6 of Advent of Code 2016. The challenge today is called chronal coordinates. The device on your wrist beeps several times, and once again you feel like you're falling. Situation critical, the device announces. Destination indeterminate. Chronal interference detected. Please specify new target coordinates. The device then produces a list of coordinates, your puzzle input. Are they places it thinks are safe or dangerous? It recommends you check manual page 729. The elves did not give you a manual. If they're dangerous, maybe you can minimize the danger by finding the coordinate that gives the largest distance from the other points. Using only the Manhattan distance, determine the area around each coordinate by counting the number of integer xy locations that are closest to that coordinate and aren't tied in distance to any other coordinate. Your goal is to find the size of the largest area that isn't infinite. For example, considering the following list of coordinates: 1, 1, 1, 6, 8, 3, 3, 4, 5, 5, 8, 9. If we name these coordinates A through F, we can draw them on a grid, putting 0, 0 at the top left. This view is partial. The actual grid extends infinitely in all directions. Using the Manhattan distance, each location's closest coordinate can be determined, shown here in lowercase. Locations shown as dot are equally far from two or more coordinates, and so they don't count as being closest to any. In this example, the areas of coordinates A, B, C, and F are infinite, while not shown here. The areas extend forever outside of the visible grid. However, the areas of coordinates D and E are finite. D is closest to 9 locations, and E is closest to 17, both including the coordinates location itself. Therefore, in this example, the size of the largest area is 17. What is the size of the largest area that isn't infinite? So, really quickly, Manhattan distance, if you're not familiar with that, is the distance on a grid between 2 points. And it's the horizontal distance plus the vertical distance. So the sum of the lengths of the projections on the line segment between the points on the coordinate axis. You can think of this as in 2D, you'd add the x and the y difference to find the Manhattan distance. In a 3D plane, you'd add the x, y, and z instead of doing the Euclidean distance, which is, the Pythagorean theorem for this. So how do we find the distance? We can subtract each point from all the other points to see which point they're closest to. How do we determine if a area is infinite then? I think if an area touches the edge of the grid, then it'll be infinite. And we'll define our grid as the minimum point to the maximum point. So we'll find the min x, the min y, and then the max x, the max y, and define that as the bounds of our grid. And if any point creates a space whose area is on the edge of the grid, we'll say that that area is infinite because it's going to extend beyond the grid. And so for all areas that do not create spaces on the edge, they will be finite and bounded by others. And then we will loop over those to find areas by the largest size. So how will we calculate size? We'll have a set of points for each area, for each coordinate, And then we'll loop over all points in the grid, add them to that set. We'll see which object is closest and then add it to it. So let's get our puzzle input. All right, so first we're going to make a list of all coordinates to iterate over. So we're going to read in this input and make a list of it. Then we're going to make our grid, so finding the max, the min x, min y, max x, max y to define the bounds. And we can do that in the same step, same for loop over all the coordinates. And then for each point in the grid, we'll find the closest coordinate. And then we will count up the points in a coordinate set. So we'll make a dict of coordinate to set of points. And then when we count it, we can also define whether the areas are finite and then find the largest set of points after we define which are finite. So let's try this. So for line in input line, all right, so we're able to get all the coordinates. We can pull out the x, y values. Then we can store them. We got to store them as integers, but we can store them in a list of coordinates. So coordinates append int x and y. So we'll store it as a tuple in this list of coordinates. Now we also need to find the min x, the max x, the max y. So doesn't look like any point is beyond 500. I don't think. So we'll preset the max to 500 or the min. All right, so we split the x and y string, we converted it to integers, we added the coordinate to the list of coordinates that we're going to iterate over later, and we are also looking for the min x, max x, min y, max y. So let's see, min x 41. Yep. Seems like nothing is smaller. There's a 47, 80, 57, 55, and then min y is 46. So 80, 46. Max x is 349, and max y is 3 59. So it looks like our grid is bound between 41 to 349 and 46 to 359. We're going to bring in the default dict library and start every single value in this with a set. And then for each point of the grid, we're going to find the closest coordinate. So for x in range min x and max x plus 1, so it's inclusive. For y in range min y and max y plus 1, we're going to get the distance between that and all points. So let's make a method. Let's first calculate Manhattan distance. So if we find the distance between 1, 1, and 2, 2, it should be 2. So 1 distance in the x, 1 distance in the y, 1 plus 1 equals 2. Great. So let's try 2, 1, 2, 2. Should be 1. This is 2. This is still 1. This is still 2. Great. So we'll see if we can correctly find the nearest coordinate. So we'll give a point. Let's call it 5, 5. We'll give a list of coordinates 1, 1, and 6, 6. Cool. So we found 6, 6. Let's replace that with 5, 5. We return 5, 5. Now let's do 6, 6 again. This time, make this 4, 4. Great. So we get none if there is a tie between any 2 points. So for each point, we're going to find the nearest coordinate, and then if it exists, then we'll put it into our dictionary of areas. We'll add that point to set. Then we'll count up coordinates areas in a set and find the largest, find all areas that are finite with no points on the edge of the grid. So we can find the infinite areas. If x is the minimum x or the maximum x, or y is the minimum y or the maximum y for any point, we will add that nearest coordinate to the area of infinite areas. So for instance, here, if A is on the edge of the grid, or here on the edge of the grid, we would say that this A coordinate is going to be added to the infinite area set. And so we're going to keep track of A, so A, B, C, and F eventually, and then we're going to return only D and E as the finite set and then find the largest finite set. So we're going to do, we're going to turn that input array into a set and then subtract all the infinite areas and then find the finite areas. So print infinite areas. And let's try it with this as the input. The infinite areas are 8, 9, 8, 3, 1, 6, 1, 1. So 8, 9 was F, 8, 3 was C, 1, 6, 1, 1 was A, B. And then the infinite areas are 3, 4, 5, 5. Or the finite areas are 3, 4, 5, 5. So we are doing this correctly. So we're able to find the finite areas and the infinite areas. So for all the finite areas, we're going to find the largest set of points. Here we get 17, which is the right answer for E. So we'll try it for the larger input set. So we get 3251. See if that's correct. All right, that's the right answer. So we got 1 gold star, and we can continue to part 2. So what's part 2? On the other hand, if the coordinates are safe, maybe the best you can do is to try and find a region near as many coordinates as possible. So for example, you want the sum of Manhattan distance to all coordinates to be less than 32. For each location, add up the distances to all the given coordinates. If the total of those distances is less than 32, the location is with the desired region using the same coordinates as above. The resulting region looks like this. So we find points that are within 32 of the others. So this is within 32 of F, and so all the pound signs are within the acceptable region. So we can go to D or E. Got it. So if we look at 4, 3 here, it's 5 away from A, 6 away from B, 4 away from C, 2 away from D, Well, so the sum of that is 30. Because the total distance to all coordinates 30 is less than 32, the location is within the region. This region also includes coordinates D and E. It has a total size of 16. Your actual region will need to be much larger than this example, though instead of including all locations within a distance of less than 10,000. What is the size of the region containing all locations which has a total distance to all given coordinates less than 10,000? All right, so let's start making this a little bit more readable. So what we want to do is for each coordinate, we want to make sure that the total distance to all other coordinates is less than 10,000 and find the region that allows that. Find the size of it. So instead of a nearest coordinate method, we need to have a def point within range of coordinates. So we want the point, the range, or the total distance to all other points, and other coordinates. So I'm going to loop over all coordinates, get the Manhattan distance from that point to the coordinate. And if distance is ever greater than the range, we will return false. Otherwise, we return true. Let's try this first with example input. We should get 16. So we got 72. How do we do that? So I added 5, 9. 0, 1, 2, 3, 4, 5. 1, 2. Oh, let's make this 32. So I added 3, 3. 1, 2, 3. 1, 2, 3, which is here. And added 6, 6. That's 3, 3, 4, 5, 6, 4, 5, 6. So let's do greater than or equal to. See what gets returned. 16. All right. So 16 gets returned. Now let's try with 10,000 on the input set. Still 47,000. Seems high, but we can try it. All right, that's the right answer. So we solved part 2 as well. If you liked this video, please give it a thumbs up and subscribe so you can know when I'm doing the next day, day 7. And when you get a chance, support me on Patreon. Thanks, and I'll see you next time.